We want to find the voltage V1 across this 6 ohm resistor in this circuit. Now the first thing I'm going to do is try to find parallel and series combinations and see if voltage or current divider formulas will help me out. The 4 kilo ohm resistor and this 6 kilo ohm resistor are in series. They share the same current. You can verify that by doing KCL here, or notice that these are the only two elements connected to that node. So I have a series combination. I want the voltage across one of them, and I know the voltage across the combination. So using a voltage divider, V1 is the total voltage, 12 volts, times this resistance, 6 ohms, over the sum of the two resistance, 6 ohms plus 4 ohms. This is 12 volts times 6 over 10. So V1 is equal to 12 times 6 is 72 divided by 10 is 7.2 volts. Now notice that none of this circuit over to this side matters. I know the voltage. This voltage source can have whatever current it needs, so it's going to supply current to both of these legs such that that voltage remains the same, and to solve this problem we don't need to worry about this side of the circuit. Now let's look at something about this circuit that's not in the problem statement. Suppose I want to find the current I1. Now these two resistors are in parallel, and I do have a current source here. So it would be extremely tempting to try to use a current divider and claim that I know the current into this combination of elements and I can easily find that. However, I don't know the current into that combination of elements. These guys here, this current in this direction is not necessarily the same as this 2 amp current because it's going to split and go in both directions at this junction here. I'd have to solve for this current, I sub x. From this, I could use a current divider to find I1.